Good afternoon, distinguished guests, ladies and gentlemen. Welcome to the Science and Innovation for Sustainable Future Symposium today. Welcome all of you. Thank you so much for your esteemed presence. Thank you very much. Distinguished guests, ladies and gentlemen, the VinFuture Prize is prestigious global science and technology award proudly originating from Vietnam. And the topics we will explore today are essential for advancing scientific progress and have profound implications for human life. As we may know, Vietnam's growing science and innovation ecosystem is helping country playing an active role in building a sustainable future. As the whole world faces rising temperatures, extreme weather, and pressures on natural resources, Vietnam is strengthening its commitment to protecting the environment. By advancing science and technology, the country is exploring solutions for clean energy, efficient resource use, and ecosystem preservation, to disseminate scientific and technological knowledge to the public, as well as connect generations of young scientists, inventors, and entrepreneurs with globally established inventors for potential partnerships. This event is held with the participation of distinguished speakers who have excellent expertise and experience in the field of environment and sustainability. And joining us today in our symposium, it is our honor to introduce to you our distinguished guests. Please joining us in welcome Professor Thuc-Quyen Nguyen, Chair of the VinFuture Prize Pre-Screening Committee, University of California, Santa Barbara, USA. Thank you so much for coming with us. And now, ladies and gentlemen, could you please kindly direct your attention to the main screen, and let's take a moment to introduce our today's topic, as well as get acquainted with our chair and our distinguished speakers through a brief video. Video, please.
The Earth is entering an unprecedented age of transformation. The year 2024 has been recorded as the hottest year in the history of climate monitoring, while the global average concentration of carbon dioxide surpassed 430 parts per million in 2025, a level unseen for millions of years. Melting ice, raging wildfires, and dwindling water resources, climate change and environmental degradation have become existential threats to humanity. According to the United Nations report at COP28 in 2023, the world is veering dangerously off track from the goal of limiting global warming to 1.5 degrees Celsius above pre-industrial levels, the critical threshold to be achieved by the end of the 21st century. Against this backdrop, science and technology are paving new pathways, from green materials, clean energy, and circular economy models to carbon capture and ecosystem restoration, to steer humanity back onto a safe and sustainable path. To foster scientific dialogue and explore strategic solutions for a green, sustainable, and humane future, the VinFuture Foundation proudly presents the Symposium, Science and Innovation for a Sustainable Future, where leading scientists and experts will share knowledge, technologies, and visions for a greener planet for generations to come. The symposium is chaired by Professor Thuc-Quyen Nguyen, University of California, Santa Barbara, USA, Chair of the VinFuture Prize Pre-Screening Committee, and recipient of the DeGen Prize from the Royal Society of Chemistry, 2023. The event features distinguished international scientists in the field of climate, science, energy, and sustainability, including Dr. Filippo Giorgi, Abdus Salam International Center for Theoretical Physics, Italy, member of the VinFuture Prize Pre-Screening Committee, and the laureate of the Alexander von Humboldt Medal in 2018. Professor Martin Andrew Green, the University of New South Wales, Australia, founding director of the Australian Centre for Advanced Photovoltaics, laureate of the Millennium Technology Prize 2022 and the VinFuture Grand Prize in 2023. Professor Daniel Kamen, Johns Hopkins University and University of California, Berkeley, USA, a leading voice in clean energy whose work has shaped global climate policy and guided nations toward a sustainable future. Dr. Jayshree Seth, corporate scientist at 3M Corporation, USA, member of the VinFuture Prize Pre-Screening Committee, laureate of the Society of Women Engineers Achievement Award in 2020. Professor Aldo Steinfeld, ETH Zurich, Switzerland, Laureate of the Solar Paces Lifetime Achievement Award from the International Energy Agency in 2024 for his pioneering contributions to renewable energy and solar fuels. In harmony with the theme Rising and Thriving of the 2025 VinFuture SciTech Week, the Symposium Science and Innovation for a Sustainable Future lights the way forward, inspiring bold ideas and transformative innovations for a greener, more sustainable world.
Thank you very much for your attention on our introductory video about our today's topic, and also we know who will be the chair and our distinguished speakers and panelists, right? And now it is time for us to welcome to the stage Professor Thuc-Quyen Nguyen, Director of the Center of Polymers and Organic Solids and Distinguished Professor of the Department of Chemistry and Biochemistry at the University of California, Santa Barbara. She's also the chair of today's symposium for the introductory speech. So Professor, please.
Good afternoon, ladies and gentlemen. It is my honor to chair this Science and Innovation for Sustainable Future Symposium as part of the Science for Life Symposia. We have witnessed science and innovation leading to better life through advancement in healthcare by solving world problems and driving economic growth. Innovation like new medicine, new disease treatment, and vaccine improve global health, while scientific solutions are crucial for addressing global challenges such as climate change, pollution, food security, clean water, clean energy, and green transportation, etc. However, in doing so, we need to think about a sustainable future for our children, our grandchildren, and many generations after them. In 2015, United Nations identified the 17 Sustainable Development Goals for peace and prosperity for people and the planet. And they called for action by all countries in a global partnership. The question is, can this vision of a better world be achieved? I believe that together we can and we will through scientific breakthroughs and innovation. In the past 5 years, the VinFuture Foundation had recognized and celebrated breakthroughs and innovation that offer solutions for global challenges. So science and innovation are also crucial for sustainable future. However, effective implementation requires all stakeholders to work together, a system-level approach, strong policy, and ensuring that diverse voices are included in shaping this innovation. We need to recognize the interdependence between socio-economic and environmental factors, aiming to create a harmonious balance among them, and that action in one area can impact or can affect others. We need to promote the transition from a linear economy, take, make, dispose, to circular economy, reduce, reuse, and recycle, to have strong policy in play and to form a global partnership. Today, the VinFuture Foundation invites leading scientists in climate change, renewable energy, and sustainability gathered here today and to discuss this important issue. We hope that the symposium will serve as a platform connecting scientists, experts, and policymakers to share insights, strengthen cooperation, and co-create a greener and more sustainable future for our planet. The symposium will start with 3 keynote lectures given by Dr. Giorgi and Professor Nguyen, and also Dr. Seth from 3M, and then followed by the panel discussion. So with that, I would like to give the stage to the first keynote speaker, Dr. Giorgi. So please join me to welcome him.
Ladies and gentlemen, and now the stage is for Dr. Filippo Giorgi, Emeritus Scientist at the Abdus Salam International Center for Theoretical Physics in Trieste, Italy. So, Professor, the stage is yours.
Okay, good afternoon, and first of all, thanks to the organizers for inviting me to this, really have to say, incredible event. Let me start by saying that after Tuesday session and this morning session, I thought I was being beamed up into a different planet, very different from the one I'm used to live in. So what I want to do, first of all, is to take you back to Earth and talk about our beautiful planet. Usually I start with a slide like this, just to remind you that when we talk about the climate system, we don't talk just about whether it's raining or it's good weather or whatever, but it's a very complex system. In fact, one of the most complex in our science. It's composed by different components, like the atmosphere, the oceans, cryosphere, and they're all very much interconnected. So if you modify one of them, you're actually modifying the whole system. Since the beginning of the Industrial Revolution, we entered what we call the Anthropocene, where humans are actually interacting with the rest of the planet in a significant way. Actually, after Tuesday's session, I slightly modified this figure because I realized that probably we are entering a new area that I will call the AI scene. So if you see somebody using this word, remember I'm the first one who invited it, because we invented it, because I think I'm realizing we're entering a new area where artificial intelligence and robots are playing a increasingly important role. How do we study the climate system, such a complicated system? The most advanced tools that we're using now are, like in many other disciplines, are digital twins of the climate system. You see here, for example, in Europe, we have a very large project called the Destination Earth, which is to develop a digital twin of the Earth, essentially, using ultra-high resolution models, observations, AI approaches, and so on. But I marked here what I think is the next challenge, next frontier of climate modeling, which is the inclusion of the human component in these models. Humans now are still considered as an external forcing, but they are internal to the system and interact to the system. So for the young people who are here, if you want to get into climate modeling, I think this is probably, at least in my opinion, an extremely exciting and difficult, but that's why it's exciting area to get into. Going to the next slide, let me say that planet Earth, I used to say that it's really under siege, not just from one direction, but from many directions. We have many environmental crises that are there. I know that there are wars, there are many problems, but around the corner there are all these environmental issues. Climate change, of course, which I will talk about mostly in my talk. But we also have a pollution issue. We talk about mortality. Air pollution is actually the third most important cause of premature death in the world, with 6 to 8 million deaths every year, especially in Asia, actually. Air pollution, as you know better than me, is a big problem in most urban areas of Asia. We have soil degradation, deforestation. We have waste covering the planet. So really, we have to, if we want to safeguard the planet, we cannot just think about one of these problems because they're all interconnected. Having said that, in this slide, you have a summary of what's happening to the climate system. These are 4 of the main climate change indicators. Carbon dioxide, as you know, it's been increasing. You saw that we reached 430 parts per million. That's an increase of about 50% in 100 years, something that our planet has never seen. Global temperature increase, It was already mentioned, 2023 and 2024 have been by far the warmest on record. The global temperature has increased by about 1.25 with respect to pre-industrial values, which means we have more or less already reached the first target of the Paris Agreement. Global sea level rise, you see here about 22 centimeters in the last 100 years globally. As you know, this may change quite a lot on a local scale. And here is what we call the intensification of the hydrologic cycle. Is a very well recognized effect of global warming, which leads to an increase in the meteoclimatic events. You cannot read the numbers, I cannot read them either, so I will tell you that, for example, compared to the 80s, the number of what we call catastrophic events, so events that I think one happened in Vietnam 2 weeks ago, maybe, big floods where many people die and there is a lot of damage, have increased by about 200 per year to more than 1,000 per year since the 80s. This means an increase about 5 times in the 80s, so 40 years, a doubling time of less than 20 years, which for climate time scale is an incredibly fast evolution. One thing that all these plots have in common is that not only these things are increasing, but they're increasing non-linearly, which means that climate change is actually accelerating. So the situation really is not getting any, of course, it's not getting any better, it's getting worse, but it's getting actually much worse than people think. Going to the next slide, just to put these numbers into context. I like to show this slide. This is a reconstruction of the temperatures in the so-called Holocene period. This is the last interglacial period that started about 11,000 years ago. If you've seen the movie The Ice Age, this was the peak of the last glacial time. It was about 20,000 years ago. Then temperatures were 5 to 6 degrees globally lower than today. Then they went up for the next 10,000 years, and we reached the beginning of this interglacial period about 10,000 years ago. And then you see the climate has been very stable for about 5,000 years. And this is what allowed our civilization to start, because people created agriculture, cities, and so on. And then 5,000 years ago, we started a slow descent to the next ice age. This is what we have been doing so far. This is about 1 degree, in fact, this is 2013, so we are higher up. This is the Paris Agreement target. This is the business as usual target. So we are giving and will be giving to the planet system a perturbation that has never seen before. And everybody who works on complex systems and sees a graph like this, they start, pulling off their hair, because nobody knows really. Our models, I don't think they can tell us how the system can respond. I need to hurry up. I have only 2 more slides. Of course, we can contain this problem. We cannot go back to pre-global warming climate, but we can, not to 1.5 degrees, but we are still in time to reach the 2 degrees target of the Paris Agreement, which is considered to be the dangerous threshold. We have many options to do this. There is no magic wand. I think you mentioned this also in another context. There is no single policy that will save us, if we want to put it this way. There are many different policies that can be used, what I call the sustainability mosaic. You have all these different pieces of the mosaic, and this is different for every country, because every country has different conditions. So you have the energy issue, carbon, the circular economy was mentioned, many other, the energy efficiency, water efficiency, and I think the next speaker will talk about this. So having said this, let me go to my last slide. So we can actually stay within the Paris Agreement target, but we need to act very fast. One of the reasons for this is that the climate system has a long memory. because there are very slow components like the oceans, the biosphere, and because the residence time of CO2 in the atmosphere is very long. After all the exchanges, on average, what we emit today will stay there for 100 years. This means that whatever we do now will be felt by the planet for a long time. And in some ways, the climate system is something that puts us in connection with the past and with the future. So our decisions, you know, I kind of see them, sorry, I go back here, let me go, oops. I kind of see them as a message that we are sending to the next generations, because we do have a choice to go one direction or another. One direction is to leave to the next generations a more hostile planet. In some places, a non-livable planet, especially in tropical areas. If we don't act soon, unfortunately, this is the direction that we'll go. The other choice is to implement some policies that will be talked about in the next talks and stay within livable conditions for all. So I think for this, science and innovation is key because it can give us informed information to actually make these decisions, and I hope that eventually will lead to the right decisions for the next generations. Thank you very much.
Thank you very much for your presentation. Thank you very much, Dr. Filippo Giorgi. So please kindly return to your seat and follow up the next part. Distinguished guests, ladies and gentlemen, now it's time for us to move to the next keynote lecture. Please welcome to the stage Professor Daniel Kahneman, Johns Hopkins University and University of California, Berkeley, USA, with presentation on innovation for just energy transition. Welcome, Professor. It's your time. Thank you.
Thank you. Thank you. Whoops. So thank you all for being here today, and thank you for organizing this session and for focusing on what I certainly believe will be seen as the most critical issue for not only our time, but for the time of our children. And as you heard in the first talk, we have a climate crisis that is no longer a surprise. There's no longer a scientific doubt. We have had 30 meetings. The most recent concluded in Brazil just a week and a half ago. And all I can say about the progression of warming is that, well, we've had a lot of meetings. And that's sadly about it. There are some details that are interesting, but basically we have talked ourselves to death. And it is time to act on that. And one of the reasons, if we were to try to pull out just a few of the key points, is that in 2025, global subsidies for fossil fuels are roughly 5 times larger than global investment in clean energy. And that's both depressing, but it's also a sign of hope, because clean energy on the technological side has made remarkable progress. Policy-wise, maybe not so much, and this is not the picture I want my children to be saying about me down the road, where yes, we made a little bit of money for a few already rich people while we ruined the planet. And there's many, many illustrations. For those who've been to New York, here we have a May day, and then just a few days later, when the wildfires in Canada, eastern Canada, blanketed the East Coast. And just to maybe put a finer point on it, the reality we saw in New York City is worse than the science fiction authors for 2049 were forecasting, for those of you who saw the sequel to Blade Runner. And just to highlight, this is just a crisis that we have all the data we could possibly need. The IPCC has been reporting on this now for decades, and yet our interest or our willingness to act is critical. Now, I'm a physicist, not an economist, so I believe adding a constraint makes solving this problem not easier, but more tractable. And I highlight that because the richest 10% of the world population contribute over half of greenhouse gas emissions. The poorest half of the planet, with a big focus on rural women around the planet, less than 10%. So our inequality our inattention to the nest we live in, as Pope Francis would say in Laudato Si, our disinterest in our own home has been severe, but yet we have remarkable ranges of opportunities. The climate story and the sustainable development indicators are linked in some critical ways. I just moved from Oakland, California, where this 10-meter poster hangs on the side of a building. I used to live in the postal code 94611. 1 digit away, 1 Hamming distance away for the computer scientists, 10-year difference in life expectancy. All of that is not due to climate change, but it's due to the disinterest in the environment for those less fortunate. I now move to Washington, D.C. If we take the metro system, we can find a 20-year gap. Not all due to climate, but it is a large contributing piece. And the sustainable development indicators, the 17 indicators, 169 sub-indicators, these were agreed upon by a lengthy negotiation process. These are goals like clean energy and clean cooking for all by 2030. You don't need to get into the details of them, although I would invite you to ask me afterwards about them. But any indicator where you see red, we are making negative progress. So our indifference to our own living environment is dramatic. Our good news is real, but as you'll hear in the next minute or two, our good news is limited to largely the technical side of the story. Whether you want to call it Moore's Law, Swanson's Law, Martin Green's Law, we are in a world where, despite underinvesting, the advances in clean energy technology have been remarkable. If we actually fought this battle with 2 hands, and maybe without the U.S. Meddling negatively in almost everything, we would have a situation where these cost improvements, these learning curves, where essentially every time we double the deployment of clean energy technologies, we see about a 20% decline in price. That's what this Moore's Law, Swanson's Law highlights. And this is a remarkable place to go. If you are a proponent of nuclear, and I say that if in a big way, we see cost increases for nuclear in the US, cost increases in France, cost decreases for nuclear in South Korea and China, and whether that's due to older technology in US and France and newer technology in China and South Korea, we'll have to see. But we've been highlighting that many technologies could be on the positive learning curve we saw for these mass-producible, dispatchable technologies, and yet we have some challenges in the larger ones. But I want to highlight that this overall process has brought us to a world where it's now cheaper to build a new clean energy power plant, be it solar, wind, geothermal, or energy storage, than it is to operate an existing fossil plant. If it weren't for the financial and political subsidies that exist for the fossil fuels, as I highlighted before. I won't do the details of the California story, but California set a goal of 20% clean energy in the year 2010. We missed that goal, but our goal of 33% clean energy by 2020, we made that in 2017. So that is no accident. That's a mixture of policy and technology. California's goal was to be 50% powered by clean energy in 2030. That goal has been increased to 60%. California, the 4th largest economy on the planet, is now running at almost 70% on clean energy and export clean energy to its neighboring states every day for the last 117 days in a row. So it is not that difficult to make that switch. California has more jobs in solar than it does in the traditional sectors, and California devoted 35% or more of its cap-and-trade revenues to do clean energy projects in underprivileged areas, creating jobs in those areas. So it's a remarkable opportunity to build things out. It's had such an impact that the price of energy at the right time of day has gone negative in much of the US West. Remember, California is the 4th largest economy on the planet. Same is true in Texas. We think of that as an oil and gas state, but it's also a wind and energy storage state. And the East Coast, well, we're working on that. Last kind of broad point I want to highlight is that this has meant that deploying more and more clean energy has brought down the price and has brought down the net demand in energy so dramatically that now we can think about bidirectional charging, sending power to our electric vehicles and sending power from electric vehicles back to the grid. Or we could do green hydrogen if you're a fan of green hydrogen. This is technically going on in a number of centers. One of our partnerships with VinFast is to work to look at and examine the ways that we can use both fleets, taxis and others, but also personal vehicles to really mix this story and bring it not only to rich economies like California or Costa Rica, but places like Kenya. Kenya is a place that is now 95% powered by clean energy. There is one of the VinFast vehicles in our lab. And I'll close with just a brief highlight to say if we're really going to lean into making more progress on these sustainable development goals, not just on climate, this is a map of the health clinics across Africa. All of those that are not on the dark lines of the grids are underpowered, frequently unpowered, and so an effort to build out clean energy mini-grids, design and build clean energy mini-grids at clinics across the continent was a major effort until the US took a very unfortunate voting turn in the last presidential election, closing US aid, but other countries have stepped in. And those of you interested to hear more will note that one of the things we're working on now is an effort to build out a new Johns Hopkins University campus in Africa to lean into these types of solutions around clean energy, around the blue or the marine economy, and around gender, land use, and biodiversity as the base of a new university to both leverage the clean energy in Kenya, but also to lean into these local solutions, clean energy for health clinics, for the cold chain, a variety of features. And this is, in my opinion, one of the small examples of what we heard in the first talk, and that is we need to lean into immediate opportunities to broaden the pool, to diversify gender-wise, ethnically, demographically, those who are taking part in the clean energy transformation. Thank you so much. I look forward to the rest of the panel, and I wish to talk to you about this afterwards.
Thank you very much, Professor Daniel Kamen. Thank you for your in-depth and comprehensive presentation with all the issues and as well as the good news that you stated. Thank you very much, ladies and gentlemen. And now it's time for us to welcome to the stage Dr. Jayshree Seth, who is the corporate scientist at 3M USA, with a presentation on sustainability and innovation. And now it's your time.
Thank you,
Doctor.
Thank you so much. We have heard very clearly the science of this situation. If I look at the title, Science and Innovation for a Sustainable Future, the future remains a question mark. Sustainable is what we need to get to, but I want to talk about the word innovation now. This is one of those words that actually is misused, abused, and overused, that it has actually lost its meaning. But if you really think about it, with all the problems and challenges that the two speakers have highlighted, innovation is the need of the hour. The original meaning of the word, the Latin root, is innovare, which means to renew. So as we sit here today, it is a day to renew our commitment to innovation. Now, if I ask you what innovation means to you, you're probably going to take out your smartphone, because that's a great example of product innovation. But just like I asked the students at Hanoi University of Science and Technology this morning, do you think your parents' rotary phone was any less innovative? That was also very innovative. What about the magneto hand crank phones that you see in Hollywood movies? Was that innovative? Absolutely. How about if you go 100 years ago and people were making smokestacks and changing the color of the smoke so one village could communicate to the other? Was that innovative? Absolutely. So our lens on innovation needs to change, because that has always been the case. Innovation is not about the conception of an idea, and it is not at the end. Innovation is actually, oops, sorry, did it show up? Innovation is commitment to the continuum. That is the commitment that we need to have, to see how we make sure we create a sustainable future. So I am representing industry today. I'm assuming most of you have heard about 3M. Maybe you use our Post-it notes to solve all your problems. Maybe you used our N95 respirator. Maybe you have used our command hooks, and I always like to give the example of washing dishes with Scotch-Brite. So that's the company that I belong to. And we have been in existence for over 125 years. We are headquartered in Minnesota. I am so glad to be here right now and not in Minnesota, because I can't tell you what the temperature is over there. And we have three big businesses that we serve our customers through. We have the industrial business, and that has the safety features also, the transportation and electronics, and then the consumer business. Most of the time you hear about the Post-it notes, which is in our consumer business. But transportation and electronics is very strong for us, as well as safety and industrial. In safety and industrial, we have things like roofing granules that can actually purify air. We have all sorts of different products in all these three, and that's why we have more than 55,000 products. So how do we think about sustainability? Sustainability is central to our science. Science for circular, science for climate, and science for community. In fact, my role, I am Chief Science Advocate at 3M, and that is part of our science for community pillar that we have. We want to be aligned with the Sustainable Development Goals. We want to invite the community to participate in science, and that is part of our sustainability framework. So how do we embed this? Any new product that I go to develop, it has to have what we call an SVC, which is a sustainability value commitment. It has to be either through the materials or processes we use, the solutions we provide, but without a sustainability value commitment, we cannot have a new product introduction anymore. That is the way we have embedded innovation in our company. So let me give you a very specific example that I like giving. So the charge for the team was to create an alternative for plastic bubble wrap. How many of you know what plastic bubble wrap is? We all love to pop it, right? Yes. So during the pandemic, there was a lot of shipping that was going on, and a lot of plastic was being used. So we were asked to develop an alternative, but it cannot be plastic. So how do you create a structure that still provides the cushioning and the protection for your package, but cannot be plastic? So the team came up with this, which is a kirigami product. So you take paper, and instead of origami, which is the Japanese art of folding, you use kirigami, which is the Japanese art of folding and cutting, and you can create honeycombs, which science will tell you is one of the strongest structures for structural integrity. And what is the beauty about this is it is also interlocking. So what we have created, this product, it comes flat. So now you can store so much more than a plastic bubble wrap, which is huge because it has got all this cushioning. Shipping of air is what plastic bubble wrap is, but we've got a flat paper. When you extend it out, it actually creates in this kirigami pattern interlocking structure. You wrap your package with it, you put it in there. You don't need scissors, you don't need tape, and you can get storage of excess material compared to that of the plastic bubble wrap. So this is the Scotch cushion lock. The reason why I'm giving you this example is this is a classic example of empowering your employees to come up with solution by defining a constraint such as you need to create bubble wrap, but it cannot be plastic. And you embed the sustainability value commitment in that. And we have done this across many, many industries. This could be our films that are used in all your devices and your laptops, which then allow the energy to be, brightness to be so much more without using more energy. Or our grid solutions, or our solar-powered headsets, or the films that I was just telling Dr. Green about, which are films that can be used in lighthouses, and they not only help the plants, but also generating of renewable energy. Building wraps that provide energy conservation. So we have tons of solutions where we are trying to solve customer problems for a sustainable future. And we are innovating for a cleaner world, we say. We have these 5 segments in which we have very specific accelerated projects. And they are our use of built environment, energy, auto electrification, carbon capture, and hydrogen economy. And as Dr. Kamen mentioned, I was just at the VinFast plant because they are a customer of 3M as well, and I went to Haiphong and enjoyed watching the cars come off and a lot of 3M products being used to make these cars more efficient. So the way I see it personally is the future is going to be about understanding of the constraints, the context, and having commitment for this innovation journey. The constraints are about the boundary conditions. Rather than viewing the limitations as limitations, you can say, these are very freeing. I know exactly what I cannot do. For example, I know that I cannot generate a plastic bubble wrap. It has to be paper. You can think of it as constraint, or you can think of it as something that is very freeing. You already know what you can't do, so you get a nice boundary condition. But now that you have a boundary condition and your area is clearly laid out, you need to get much, much deeper in your understanding of the context. This is where a lot of companies, a lot of organizations fail to do. Getting context means talking to users, talking to people, interacting with others, and it also means the team that is solving the problem cannot look the same, feel the same, think the same. They cannot be from the same college, the same community, the same country for that matter. This is where you need really the diversity of thought that our world offers us. So the teams that have that are going to really understand the context deeply given the boundary conditions. And then finally, commitment. The kind of innovation that we need requires radical collaboration. It is not just top to top. It is eye to eye, bench to bench on vision, mission, and roadmaps. And that requires really boundaryless behavior if we are to solve the challenges that the two speakers talked about. So I really think the future is about constraints and understanding them, context and enriching it, and commitment for this innovative journey to a sustainable future. So this is what I like to say, now more than ever before. Innovation is a lifesaver for business, absolutely. But inspiration is the lifeblood of innovation. And purpose is the lifeline for inspiration. So for the students who are driven to do something for the future, this is so important because you are driven by purpose. That is a motivator, if there ever was. Thank you.
Thank you very much, Dr. Jayshree Seth, for your amazing presentation. Thank you. Distinguished guests, ladies and gentlemen, we know that our distinguished speakers and also our audience are looking forward to the panel discussion, right? But before we moving to the next part and meet our panelists, please pay your attention to the main screen and let's take a moment to watch a short video clip about VinFuture Foundation throughout 5 years. Please enjoy. Distinguished guests, ladies and gentlemen, that is the journey of VinFuture Foundation through 5 years. And tomorrow evening on December the 5th, the VinFuture Prize Award will be taking place, and we will know who will be the laureate of special prizes and especially the grand prize. And now the stage is ready. We will come to the panel discussion today. Please join me in welcoming to the stage Professor Thuc-Quyen Nguyen, the chair of the symposium discussion. Welcome to the stage Dr. Filippo Giorgi, Professor Daniel Kamen. Welcome to the stage Professor Martin Andrew Green, Dr. Jayshree Seth, as well as Professor Aldo Stanfield. Please welcome our panelists. And now the panel discussions will be moderated by Professor Thuc-Quyen Nguyen. Enjoy your stage.
That were really wonderful talk to hear from, like different sector, especially the industry part. So I didn't know about the bubble wrap and the paper, and so that's really wonderful. So then, you also mentioned about California be able to meet the goal much earlier, right? So talking about the policy, so we wonder what is the most urgent action policymaker need to prioritize to close the gap between commitment and real-world implementation?
Well, thanks so much. So, I mean, California makes a lot of mistakes, but they've also charted a path here that's worked quite well. We already have a clean energy standard, a commitment to be zero carbon, a net zero carbon economy, although we're not exactly sure what net zero means, but we'll leave that aside, by 2045. But the next steps are really to accelerate some of the key sub-goals. So for example, right now, electric vehicles are sold around the world. Some places like Norway, almost exclusively electric vehicles. But no country or no municipality has stepped forward to say, we will only accept electric vehicles if they are two-way. So they can buy power from the grid and they can sell power from the grid. That's a natural next step. The part costs about $30 US. And once you have the technology, it's much easier to force utilities to accept it. And that gives us a massive fleet of mobile batteries that could be plugged in wherever. So that's one natural thing. The other thing is unfortunately a more socially delicate issue, and that is many companies that do business in California have said they cannot find enough good projects to do that focus on women leaders, that focus on minority communities to spend that $4 billion or so a year of revenues. And many people in the environmental justice world have a very undelicate swear word for that. And they say, you're just not looking for the projects that elevate minority entrepreneurs. And so I think that's the next stage, to really lean into the words and to promote diversity in science, something that we are seeing zero of at the federal level in the United States right now.
So, Professor Giorgi, so how about in Europe, in terms of policy, maker, how to close the gap or the implement or commitment from, or Italy or from the European Union?
Well, I'll talk about Europe first. I think it's, in Europe we have the Green Deal, which is quite advanced actually compared to many other countries. There's this very ambitious target by 2030 of going essentially to almost zero net emissions. But now, unfortunately, there are some governments that are kind of resisting this deal, and there's a lot of discussion, internal discussion within Europe, and also within Italy. Also, let's say that our administration is a bit not very, how to say, oriented towards environmental issues. Also, in Italy, we have a big problem, as Aldo knows, of infrastructure to support this green transition. For example, if you have an electric car in Italy, as Aldo knows very well, it's not easy to get around. So there's quite a bit of work to do. There's big differences between one country and the other. But overall, I think Europe is on the right path, I would say.
So thank you. So we all mentioned about the energy throughout the talk, and you just also mentioned about charging and infrastructure for the energy transition. So I would like to ask Martin, right? So in your opinion, with the disruptive innovation in the energy or sustainability material sector, do you believe to hold the single greatest game-changing potential in the next 3 to 5 years, the short term?
Yes, I'm mainly involved in solar photovoltaics, and I guess it's been quite an unusual technology in that it's exceeded every expectation about how quickly the technology could evolve and how quickly it become cheap and so on. So I've often been accused of being over-enthusiastic in my promotion of the technology, but the costs and the volumes that are being produced now have exceeded every forecast that has been made. And the really good news is the costs are still going to come down. So it really doesn't need any big breakthroughs. It's just this incremental evolution of the technology that Dr. Seith mentioned, which is really driving the costs down. So, but there are technological advances that can be introduced, and you know, the solar cells now have the energy conversion efficiency has increased greatly, but there's potential for even doubling that, and you know, I think we're going to see that happen over the coming decade. So, to my mind, it's more in the political arena that changes are required for the technology to fulfill its full potential. The industry has shown it can accelerate the manufacturing volumes very rapidly, and they have been growing, you know, doubling every 2 or 3 years. But you know, it could grow even more quickly than that.
Thank you, Aldor. I know that your work also related to solar, but different aspect than what we're discussing. So, what would be your opinion on the next kind of the breakthrough technology in this sector?
Let me address your question specifically in the field of solar fuels. Both material sciences and engineering are crucial for the development of new technologies. In terms of materials, I believe superior redox materials that are capable of splitting water and CO2 need to be discovered. Very promising is the family of perovskites. And many groups around the world are very active, screening all the possible combinations using computational techniques and also experimental techniques. In terms of engineering, I believe there are two critical aspects. First, very challenging is the design of energy efficient solar chemical reactors and their scale up. From the laboratory setups that we have at the university all the way to the industrial solar refineries of the future. And a second important subject also related to engineering is the integration of energy storage into these plants so that we can deliver solar energy 24/7 continuously and operate these chemical plants at a commercial level. Yeah.
Thank you. So the question is for Dan, because you mentioned a little bit in your talk regarding of Africa, right? So how can we ensure that the new green technology are not only scientifically efficient, but also make accessible and affordable to all nations, thereby preventing an innovative divide?
Well, so I think actually where 3M and other companies are critical, because we don't want to replace a fossil fuel export economy with a renewable energy export economy. So indigenizing the materials, Africa is the source of many of the critical materials, and so finding ways to first do assembly, and then manufacturing of advanced batteries, whether they are flow batteries or solid-state batteries. These are technologies that could be manufactured in Africa, bringing jobs right to the place where a lot of the materials come from. So that would be one natural way to integrate more fully Africa into the global economy, providing jobs. We already know that many of the smelters of critical materials are women, and so there's opportunities to lean into projects that promote local manufacturing, clean manufacturing, to really up the game so these are not all exported from China, exported from US, exported from Europe, and they become part of the local economy.
Wonderful. So since we talk about sustainability, right? So I'm just curious, would love to hear from 3M, like you mentioned a little bit of that in the talk, but in terms of the efforts of reuse less, reuse and recycling, so I would love to hear the strategy on that.
We have strategies for every aspect you can imagine.
Good to hear.
And we have active initiatives in every aspect you can imagine. But at the end of the day, a company has to make some tough decisions. And it depends on the customers, the problems to solve, stakeholder expectations, and shareholder expectations. So at the end of the day, the decisions that are made may not reflect all the activities that are going on within the company from a technical standpoint. So I can assure you that we have scientists, my peers, who are actively working on all the problems that we're talking about. But it all comes together when there is a customer, there is an incentive, and there's a reward at the end. So what we're trying to do is part of the stakeholder spectrum, saying that the green economy has the impact everywhere. There's an ecological impact, there's economic growth, and there's emotional fulfillment for the workers. And that all has to come together. And because of reasons that have been mentioned before, the pendulum swings sometimes, and that's beyond our control.
So also, Martin, right? You're the expert in the solar photovoltaic. And so we see now everywhere around the globe, like silicon solar cell module. So in terms of the recycling and reuse, and because I heard this comment, like now they start pile up the earth, and it's cheaper to buy a new solar module than it costs a lot more to recycling the solar module. So I am just curious if you can give some thought in terms of in Australia or in other regions in this effort.
Yes, so I think if you look at the amount of waste involved, it's not really as large as you might imagine. So one of my students did a calculation a few years ago, supposing all the world's energy was supplied by solar photovoltaics, and he calculated that it would add 40% to the present glass waste stream, which comes mainly from building waste and so on. So you'd rather not add 40% to the building waste stream, but it's not like it's adding a whole new dimension to the waste problem that we already have to deal with. So to some extent, I think the issue is over-exaggerated, but I believe that, as a responsible industry, we should be looking after it, and many people in the field are working on developing recyclable technology. So in the past, the panels have been made to last forever, and they nearly do that. But now more thought is given to designing panels that have a finite life and at end of life can be easily dealt with. So it's definitely a growth area within the industry, and I think all manufacturers are giving serious consideration to it now.
Wonderful. So the next question I would like to ask Filippo, how can accurate climate science projects so that regional model be more effective, integrated into national adaptation and risk mitigation strategy, especially in certain vulnerable regions?
Yeah, actually the modeling world has done incredible steps recently. The use of these regional models, for people who don't know, these are models, it's like a zoom lens, you know, they can focus on specific regions and give very detailed information, which does not necessarily mean more accurate information, it depends. It's a very important tool, especially for countries that don't have big resources to build these big global models. In fact, we have in collaborations with Hanoi University on developing regional models for Vietnam, and they can provide regional know-how as well to improve the models. So I think we now can go to very high resolution, even 1 kilometer, improve the simulation of events like the one that just happened in Vietnam, so these extreme events that are the most important, and empower the local people. These models are used in Africa, for example, in South America. They're used everywhere now. So I would say, of course, climate change modeling is, climate change prediction is a difficult task, especially when you go to very high resolution. But also with the use of AI, the models are getting better, the observations are getting better, and now we feel that we can provide information that can be very useful for adaptation measures. In fact, I do think that the climate, I don't know if this is done everywhere, but the climate change component should be included in the planning. I know that some countries do it. In Europe, definitely some countries do it. In Italy, some regions do it, some others don't. But I think climate change is here. We feel it every day, so it has to be included in our planning for the future.
So I am curious because both Dan and you work on the model and prediction. So are these available like any other scientists, for example, in Vietnam, in India, and other places, they want to use the model and make modification to their region, so that open access?
Actually, this is what we do. There are a number of these models available. In our institute, we have one that, again, we've used with the Hanoi University as well. These are public. We organize workshops. In fact, I've been here for a workshop to work with the students and the junior researchers to learn how to run these models. And especially, it's not so much an issue of running, but interpreting the results, knowing the physics that is behind and why things happen. You know, the models produce numbers, but you have to be able to interpret those numbers, as you well know. That's a big step, and that's where we come in, trying to really teach the students how to use these models. So, yeah, they are available. There's not only one, there are several. They can be adapted to all the different regions, and that's where the local know-how comes in. So these are I think, very important resources. And that's what I've done most of my career. So I'm really happy that now many people are using these models. Yeah.
Great. How about you, Dan?
Yeah, in fact, the Nobel Prize in Physics was recently given for the modeling. Suki Manabe and others received it. I do think that one of the issues is that the models are available. They're open source. Many, many scholars use the so-called RCP3 as sets of models, different scenarios. Often the data is the hard part. And often getting localized data with not just data in a data set that sits in Berkeley, California, or sits in Italy, or sits in Berlin, but is really locally useful. But the outputs have been dramatic. So currently the largest and the most productive wind farm in Africa is called the Lake Turkana Wind Farm. It's in north central Kenya. And it was discovered through the use of these models that this is an incredibly good wind resource. Similar effort took place in the Atacama Plain in Chile. Regional and RCP model for Latin America was used, and now they have exceptional solar. It's some of the best solar installation in the world in the Atacama. And it was known qualitatively, but wasn't known in a way that made it comfortable for investors, for companies to jump in. So there are real clear examples of we wouldn't have this clean energy project without the kind of hand-in-glove work together that we see in some of those efforts. But I do think there is a challenge, and that is that we like to get good at models, and they say that models are only as good as the strongest proponent. That's usually the model creator. And so in many areas we have a great energy model, but we have a very poor water model. And in many parts of the world, we have traded one crisis for another. We're now quite good at clean energy, but we're very bad at water. Or we're quite good at water, but we're now bad at smart agriculture. And so being more holistic, being trained outside your discipline, working with colleagues is something that we're not very good at yet. We talk a lot about it, but we're not that good at really working closely together across fields.
That excellent point, Dan, and thank you. Because this is, we discussed earlier about how to educate all the stakeholders, right? And I would like to ask Suray, what role can corporations play in educating the stakeholder ecosystem?
Yeah, I think what you said is brilliant. We talk about the idea of collaboration, but do we have the mindset that is necessary now to actually make this happen? And it'll require some radical collaboration. I mean, some of the playbooks have to be tossed out and new workbooks written because of the things that are needed now. And I think corporations have an important role to play because in many ways they have a very strong pillar as it relates to taking work from the academia, converting it into real products, and having the economic as well as the ecological impact. The problem is back to what you said about collaboration. The academic work has to be such that it can be scaled. So from the beaker to the boatload of material, there's a long journey that needs to happen. And who is going which way to bridge that chasm becomes an important thing. So educating the stakeholder spectrum in terms of academia is it's not enough to have that aha, we can solve this problem. How will we go about solving this problem knowing this is how business works, or this is how policy works, or this is how the public works? So if I take 2 or 3 steps back, I feel personally that we need leadership in organizations that has more of a legacy focus. And that means thinking a little bit about the long term and having the gut and the gumption to do so. I also think we need allyship and advocacy across the value chain. We're not going to be able to make a certain material if we don't have the raw material in order to convert it into a semi-finished good. So this value chain becomes very important. Then we need the partnership and the primacy of the public, because at the end of the day, the public needs to be bought into that. And many a times we forget about the public. But we do research on the public perception of science, and we are shocked every time when people say, if science didn't exist, my life would be no different. 40% of the people said that in a survey. So, and they were taking the survey on their laptops and mobile phones. So you see what the problem is. People don't realize that science is invisible, science is underappreciated, science is taken for granted. So we really need to bring that up. And the academics sitting in their ivory tower and the business folks sitting in their purses, we are forgetting the public. And the public has a very strong role to play because it impacts us directly or indirectly based on some of the things that you mentioned. So, and the last one to me is stewardship and diplomacy across the ecosystem is important. And diplomacy, wow, yeah, we need that. And we need the environmental stewardship. Only then does this whole mosaic come together. Otherwise, we're all doing our own thing and calling victory while we're all losing the collective game. So not very concrete, but I think it's simply things like having those across the stakeholder interactions that are active, take a problem to solve, and everybody figures out what they do well and what additionally they have to do to make it happen. And each one has to do something additional to bridge those chasms that exist between all, be it academia, be it government, be it policy, business, and the public.
That's wonderful. Thank you. So we talk about green energy and energy transition, and many of us get here by airplane, right? So EV vehicle that at least, you know, that we get there and we see everywhere, but in terms of airplane, transportation, right, aviation. So I would love to hear Aldo. You shared a little bit earlier to me about the research in that sector, and we would love to hear more on that.
Thanks for the question. Yes, indeed, aviation is perhaps the most difficult sector to decarbonize transportation sector. And this is, well, for short-range flights, one can think about using rechargeable batteries for electric motors. But the range cannot exceed 1,000 kilometers. Physics is telling you. So perhaps you can fly from Hanoi to Ho Chi Minh, is about 1,000 kilometers, but you cannot fly beyond that. There is, for long-range aviation, there is no way around jet fuel. This is the kerosene, the hydrocarbon. And these days, if you are following the discussion going on in aviation, the key word is sustainable aviation fuels. How we can produce sustainable aviation fuels to decarbonize aviation. And one way of doing that is by using two ingredients, sunlight and air. May I elaborate a little bit? So two ingredients, sunlight and air. How do we go about it? First step, you extract water and CO2 from the air. Water from the humidity, and you extract CO2 by, for example, direct air capture technologies. Second step, you use solar energy to split water and generate hydrogen, to split CO2 and generate CO, carbon monoxide. This mixture, hydrogen and CO, is a magical mixture. It's called the syngas, synthesis gas, because this is the precursor for the final step in this process chain, which is the processing and liquefaction into the so-called drop-in fuels, such as synthetic jet fuel. This synthetic, I like to call it the solar jet fuel, is burned in the jet engine of a plane. The combustion of the fuel emits CO2 into the air, but it emits as much CO2 as it has been extracted from the air from its production. Exactly the same amount. Therefore, this fuel is a sustainable, carbon neutral aviation fuel.
Wonderful. Thank you very much. I think I would love to sit here and continue to discuss, but since we would like to have some time for questions.
Thank you very much, Chair of the panel discussion today, and thank you very much, our panelists. Thank you for your message and conclusion. So now it's time for us to open the Q&A sessions to hear and listen to your voices with the questions to our panelists. So don't hesitate to raise your hands to deliver the questions so our staff can assist you with the microphone. I want to see your hands. Yes, please. On the third row. Yes, right in the middle of the ballroom. So our staff can assist our guest with a microphone. Right in the middle of the ballroom.
The young one first. Sorry.
Thank you. Thank you very much for the panelists. I would like to ask a question on Vietnamese context that we are now kind of fighting two fronts at the same time. So this year, as you had already mentioned, we have the most rain over the decades. 2 years ago, we have the hottest kind of years along, few decades. So basically, we are talking about 2030, 2045, but in Vietnam, we are experiencing it right now and it costs a lot of money. So I wonder, first of all, from the technology point of view, do you have any suggestions for climate resilience technology that could have us to have a short patch, fix this problem? And also, in terms of 2035, 3045 is long term. In the recent term, in the shorter term, in terms of investment, what kind of policies or from the corporate point of view, what kind of technology you would think that would be best to invest?
Thank you for your questions. So, panelists, please.
Who would like to answer the question? So,
Energy policies.
so if I understand the question correctly, you talking specific about recent flood in Vietnam, right? And also in other part of the world. And so you would like to see what could be the recommendation or suggestion for the short term and also for the long term.
Recommendation concerning what exactly?
The flood, the climate change, and all the severe weather.
You mean how to manage this?
Yes.
Oh, okay.
The short term, yeah, and also the long
Yeah.
term.
Okay. I'm a climate modeler, so I'm not sure I'm the best person to answer this. But okay, we cannot predict these events way ahead of time. Okay. I think there's a bit of confusion between weather prediction and climate prediction. These are two very different things. Weather prediction is predicting the weather 1, 2, 3 days ahead. And we know that there is a theoretical limitation for this, which is 7 to 10 days. Climate projections is a different thing. It's you try to understand what is the how the statistics of events change because changing forcing like CO2. So we can expect that events like the flood that happened in Vietnam may become more frequent. We cannot say when and where they will happen. What we can say is that they will happen more and they will be more damaging. We can expect that heat waves will be more intense, although we cannot say when and where. So how to adapt to this? Again, it's a matter of doing long-term policies, which vary from region to region. And now I don't know about the Vietnam situation, so it's difficult for me to make specific recommendations. All I can say is that we know that these things are going to happen more and more. So we know that we or you or everyone has to do something to adapt to these new conditions. And so these considerations have to be put in place when you actually do planning for the future. So this is as far as I can go. Now, in terms of specific recommendations on how to address this, these are more technological questions, I think, that I don't think I'm in a situation to
Very challenging.
Yeah.
Thank you very much, our panelists, and thank you for your questions from our audience. And our panelists, we not only have the offline questions, we also have the online platform where many questions are delivered to you. So may I send it to you with the questions from online Zoom. So the question is, how can innovation and industry leadership accelerate sustainable development while remaining inclusive? So panelists, could you please address these issues on the online questions of it?
I think the only way is inclusive innovation. I think that's the only way forward. We as our company, we have committed to those goals, and it's part of our strategy. And if you look at our entire sort of larger system, imbalance in one is going to impact our own, close to our proximity. So I think being global in our operation helps us tremendously.
Yes.
So for example, 3M is in many, many countries around the globe. So we are plugged into what is happening in a global scenario, which makes us inclusive from a global perspective. We are also investing in making an equitable STEM robust ecosystem, which helps from inclusivity in other areas. So I think that's the only way forward. That is my personal thought.
Thank you very much, Dr. Jayshree Seth. Thank you for your answer. And now we have one more question from, yes, the gentleman in the fourth row. Thank you.
Yes, thank panelists for the question. So my name is Dr. Nam. I'm also the founder from the Climate Innovation Consulting in Vietnam, and also I'm the UNFCCC reviewer for nearly 10 years. I have the question based on the speaker motivation. They said that Vietnam right now, we have a lot of commitment for the global climate change, and also we have some many regulations to foster the green transition in Vietnam. And also we have a lot of innovation activity, like for example from VinFast, for a lot of activity, not only for the environment, but also for the community in Vietnam. Yes, so my question is, any suggestion for more than initiative in developing country like Vietnam, how we can scale up a lot of activity like VinFast or any green initiative in developing country? I understand that local experience is very important, and only the science, only the industry cannot work alone. So they have to work together. So I expect any suggestion from your views that is some scientists in Vietnam or developing country can contribute for the green transition in our country. Thank you very much.
So Dan, you would like to take that question?
Yeah, so I mean, it's a great question. I don't think there's any single answer, so I'll only just address a part of it. But my experience in California, where many countries look at Silicon Valley, sometimes they look at what Silicon Valley really is, sometimes they look at a kind of a fairy tale version. But for the last 3 years in a row, University of California, Berkeley has produced the most new clean energy companies and the most diverse leadership by having programs that focused on women entrepreneurs, on minority entrepreneurs. And teams from Morocco and from Kenya have each studied Silicon Valley in its real operation, not like in the movies. And what they found over and over again is that governments and existing companies need to give space for innovators to fail as a learning process, not as a process to exclude. And there are many countries where if you try to found a company and it doesn't work, you're really shuttled to the side. And in Silicon Valley, for a variety of reasons, and maybe in the innovation ecosystem around Nairobi, the one in Kenya, in Morocco around Casablanca, these are places where you can try, and there's support for your first effort and your later efforts. And they've led to more diverse, more climate impactful companies than any other region. And it's not even close. Berkeley, which has invested a lot of money into this, of course they have some money to invest, which is nice, more than 30% more new clean companies than any other university and ecosystem in the world. And so that's something they're proud of. They just wrote a book called Startup University, all about how to do this. But I do think it requires local leaders to give space to try and fail and still support those who want to make that gamble.
Thank you so much, Professor Daniel Cameron. So panelists, any one of you want to add some more information for the entrepreneurs in Vietnam for the goal of sustainability? For that, questions from our audience.
We have one question over there.
Thank you very much. So yes, may I have the last spot for the last questions from our audience, please?
Okay, thank you very much. So the last but not least, okay. As you know that, I'm very interested in all of your presentation here because all of you are famous, all are famous in the world, the famous in the world. And as you know that we are living in the VUCA, volatility, uncertainty, okay, complexity and ambiguity. Very important thing here. But I have two questions. The first question, you should provide us maybe some main or key principle for sustainable sciences and innovation. You should know that science and innovation for a sustainable future. But what is the sustainable sciences and innovation? And what are the principles for this one? Because you don't know what's the principle. So when you provide a lot of things, we cannot identify what is this. Very, very difficult. Some people say that climate change. Some people say that maybe weather change. Some people say that people action change. And some people say that maybe for Kondrachiev waiver. We don't know what is it. So we should provide at least 3 main principles for sustainable sciences and innovation for us to know clearly about these topics. And the first question. The second question I would like to know is whether or not do you agree with the statement from Kondrachiev provided more than 100 years ago. We talked about a Kondrachiev waiver. That is talk about the maybe natural law of climate change, not just only very small parts from the human action. So if just we base on such one, we can provide a precise prediction about the climate change in the future. That maybe we try to avoid a lot of maybe natural disaster. For example, in Vietnam, we are a lot of intelligent people, but we have a lot of Vietnamese people die by natural disaster.
I am so sorry.
Okay?
I'm so sorry, sir. So the time is limited.
Okay, thank
so
you very
yes.
much.
So can you sum up with one question? So panelists, please.
So anyone would like to answer the first question regarding of the science, the innovation, and sustainability? Our colleague would like to know clearly, define clearly the 3.
I mean, I think my prior answer was part of the story, and that is you need to support ecosystems, and it takes the government, it takes universities, but I also think it takes elevating sustainability as a field. You can't say, oh, let me go find a mathematician, let me go and find a material scientist, and tomorrow go solve sustainability. There has to be an ecosystem, there has to be a community that recognizes this and works together. And it's not the whole solution, but I do think you have to make this into a field. You can't train people just in disciplines and then overnight expect they will somehow work across areas. So, and I tried to address that in the prior one, but I think the spirit of the question is really challenging, and that is, how do you support those playgrounds, those ecosystems where people will want to work on this and they won't be drawn off to other more traditional fields because it's clearer how to advance. You have to make this a go-to intellectual and business destination.
I really like that. And it go back to echo all the point with we need to involve all the stakeholders and education and the public awareness. And I think that's very important.
Yeah, if I may add to what Dan said, I really think we need a new breed of scientists. Something that now is, at least in my experience, maybe in the US it's different, I don't know, but I think this interface between the science and the, okay, you can call it stakeholders, you can call it the users of the information, is a very different, very difficult interface. We really speak, I mean, look, I've talked for many, many years with people. Somebody asked me, how will the weather of Venice be in 2075? So, of course, nobody knows. But I think there need to be people who understand both worlds and can translate from one to another, and so that the two worlds can actually understand each other. Because my experience is that the expectations are very different, and what we can provide is maybe not what is expected. And so this needs, as Dan was saying, a specific training, is, you know, again, educating a new breed of scientists at this interface. And to me, this is a big step. And I hope that the universities actually will pick up this at some point.
Thank you very much, Dr. Filippo, Giorgi, and also thank you very much, our panelists. And with that conclusion, our panel discussion is coming to an end. Thank you very much for your attendance, and especially thank you very much, our distinguished speakers, for your participation and discussion on various issues on environment and sustainability. And we still have time for the breakout session with 3 rooms for 3 assigned topics, and the session will last 1 hour to 4 and 5 p.m. local time. And don't forget to watch VinFuture Prize Award ceremony will be taking place tomorrow evening, December the 5th at Holgum Theater One more time, thank you very much for coming with us. Goodbye for now and see you again.